Alright, I figured I'd show off my new toy I got in the form of a 3D accelerometer gyro magnetometer thingamabobber. And basically what it does is it allows me to, in this use case, check control surface throws. So even though it's three-dimensional, it has an orientation configuration that allows the Kalman filter inside here, which is the attitude estimation algorithm, to calculate angles. And it's a convoluted set of algebraic matrices, and it's actually utilizes quaternions to prevent gimbal lock. So it's all higher mathematical bullshit that is candidly beyond me. I know enough just to be familiar with it. Anyway, that's why the airplane's sideways. Because I have this thing set up for horizontal implementation, and instead of going through the process of recalibrating it, it was just quicker for me to throw this thing in a vise and set it up. So, anyways, I've got the device connected to the phone. The phone has an app that's running. It gives me the data from the gyro. And if we reset the angle reference to 0, in theory, that zeroes everything out. And then if we're looking at the Y figure right here, if I throw one direction, I've got negative 38-ish. It's going to go to negative 39. So negative 39 to 36.5. So that's a 2.5 degree spread ish. Which I'm not worried about because gravity's playing a role here, and the weight of this is affecting the rudder centering on the servo, etc. So I'm pretty good with that. So that's what, 36 to 38 degrees in high rates. If I go to low rates, we're looking at 20 to, oops, this thing's shaking. That might be playing a role. Okay. Yeah, so we got 26 in one direction, 27. And 21. So 21 to 27 is a 6 degree spread medium. And if that was low rates. So 21 to 27. So 6 degree spread and low. If we go to high rates, that's 38.5-ish. That's going to be about 37. So, in high rates, I've got relatively uniform. I'm going to end up probably seeing if I can go all OCD on it and get it even, but the main purpose of this video is just to show the usefulness of being able just to clip on a surface, making sure it's square and level, and then throwing the control surfaces and getting the readings. So it's 38, 30, it's probably going to settle out at 39. I'm not going to wait for it. 39, and it's probably 37 when it settles out. Yeah. So it's 2 degrees spread in the high and a 6 degree spread in low. Interesting. I know gravity's playing a little bit of a role in that because the weight of the sensor on the very end of the rudder, there's a pretty large moment there. So next will be the elevator. All right, I'm back. Excuse me. I've since repositioned the airplane on the device, and it's not quite level. Let me make some small tweakage here. That looks pretty good. Let's tighten that up, make sure that's tight, and then we put this gyro on the elevator. In hindsight, I should have gone with a bigger clip, which I'll do. That's one of the reasons I did glue on this instead of hot glue instead of a more permanent mounting, so that if I need to make a change I could. Alright, so that looks pretty perpendicular and pretty much level. Let's see what the app says here. Shitsky connect scan. Oh, it must have turned off. No, it's on. There it is. Alright, my device. Reset. I'm gonna tell it to set the angle reference. And then, oh, fuck. And then if I go to angle, and we're dealing with elevator here. So, I've got 39 and change. And 41 and 42, 43, I'm guessing. Yep, 43 and change. $39 and change. $43 and change. So spread of 4 on high. Low rate. If we go low rate, $21, $22, somewhere in there. And -20, so that kind of makes sense. 2 degree spread in low. High rate. -39. 43. Okay. So it's a 4-degree spread there in high. Excuse me. So that kind of makes sense. So elevator I'm happy with, other than maybe centering that a little bit on the throw limits to get uniform throws left to right and up and down. Deal with the rudder. And then if we look at the, and this one's, these are difficult because they're trapezoidal, or yeah, they're trapezoidal and swept forward. So I've discovered through using this that you kind of have to be picky about, I guess that's okay, and zero it there. So if we look at set angle reference, I am always doing that. And if I go angle, excuse me. Okay, so we go to high rate. And I've got, I'm on the y-axis just because of the way it's oriented. But if you look, when I pitch this one way, you'll notice that the x-axis deflects quite a bit. So that means I'm not quite right. So if I tweak that just a little bit, that wasn't quite enough. Oops, that might have been too much. Let's see. No, that's pretty good. So that's, X stays pretty reasonable. Y, it's close enough to zero at neutral aileron deflection. So if we go max aileron deflection, I'm at negative 19 and change. And positive 20 in change. And that's in high rates. If I go low rates, yeah, see that's 10 degrees and negative 10 degrees. So I've got some requirement to fix the elevator or aileron throws to increase them, and that's going to end up having to get done with the longer servo arms. Tweak, and then I need to fix. So anyway, that's what I wanted to demonstrate, was the use of that as it relates to control surface throw testing. No wires, no goofy mechanical devices. As I get better with it, I'm sure it'll become quicker. Obviously, I need to make the clip a little bigger, just to make it easier to grab on the control surfaces. And interacting with the app, I might be able to get away with not only having it on the ailerons and the elevator when the airplane's straight and level, but also on the rudder without having to put the airplane in a goofy attitude for testing the rudder throws. That's it. Take care. Have a good day.